So we're asked to solve the system by graphing. So that's the first way we learned how to solve. So we're going to go ahead and do that right now. And I realize that you probably are very familiar with this if you did your homework, not so much with this format. But really, you know, it shouldn't matter in which format the equations are given to you. You can still graph them, right? This is still very much drawing from your knowledge in chapter 6. So just because the textbook has it in this format most of the time, this format is called standard. We learned about slope intercept, slope point, and general. As soon as you bring that constant over to the right side, it's called standard. And the reason why this is presented to you is because most of the time when you model a word problem, it will end up looking like this because you have the two variables on that side and then it's going to be equal to a certain amount on the right side. That's the main reason they set it up like that, because you will see in grade 11 as well, you will set up systems and then solve, right? You'll also be dealing with inequalities. Okay, so let's go ahead and graph this. If it's in this format, your best bet is probably to rewrite it. So if you want to call that 1 and this 2, right, then you kind of know where you do your work. Right, I will rewrite it. I bring the 2x over subtracting, and the 15 is already there. Divide everything by -5, and you have y is equal to 2/5 x minus 3. So there you know, right? You don't have to write this on a test or AC, but we start with the intercept and then use the slope of 2/5 positive, so we know this is going up, okay, towards the right. And then the second one here, that one I would argue not to rewrite. You know that this is in slope point form. So we will start at, you take out the x, it's -1, and you take out the -3, which turns positive. So we will start there, and my slope is -2/3, right? Meaning that my line is going to go down from left to right. So that's actually almost easier, even though it's scary looking, right? It's easier. So when we graph, it's probably a rule of thumb to use, go 10 in each direction if you have to do this by hand, okay? So, and then just make the segments small enough to fit, okay? So I chose to do this by hand because that's where most of you are at, right? So you have your x and your y, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you do that, make sure they're spread out equally, right? And then do the same thing this way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So because you have to do this by hand, I wouldn't make the answer be too big, right? So it'll be reasonable. And then it's 1, 2, 3, 4, 5. I might run out of room, but for now I'm just gonna leave it like that. And then it's 1, 2, 3, 4, 5. You kind of develop, it's almost like an art, right? Where you just move your pencil steadily, you create those gaps. Some of you have graph paper, some of you have the grids, great. But if you're doing it by hand, it's gotta look nice, okay? And so we're gonna start with this one. 0, -3 puts me right there. and I'm using a slope of 2, 5. So you got to be careful here. You're going to go up 2 over 5. So that would put me right here. Okay. If you wanted to do another, you go 1, 2 over 5. That would be right there at 10, right? So let's see if it lines up. Not 100%, but I'm going to make this work out somehow. So I understand, right? Then you just make the dot a little bit bigger, make it work. 2x minus 5y is equal to 15 is graphed right here. Okay, and then you use your other point, which is -1, +3. It's right there. And then you use a slope of -2 over 3. So you're dropping 2 and you run 1, 2, 3. And then you drop 2, you run 1, 2, 3. So you're supposed to line up right with that dot right there. And again, my graph isn't perfect because it's by hand, but I will be able to see enough evidence of the fact that you've done work, right? So just make this dot a little bit bigger so it fits, right? There it is. And this is the line y minus 3 is equal to -2/3 x plus 1. If you wanted to rewrite that into slope-intercept, go for it, but I think it's a lot of time that you're spending on something that isn't really needed, okay? And maybe I will, in your notes, put down that this is slope point. This is standard form, right? So you identify, you're still looking for that, right? And so now the point of intersection of these two lines is right here, which is 5, -1. If you're solving graphically, we have to make it be a round whole number, okay? That's one of the reasons why you would want to solve by graphing. Even if it wasn't, you'll see later on with the other methods, we can figure out exactly. And then if you were to graph it, it should be very close to what it is. But when it's graphing, if you're solving by graphing, chances are it's going to be a whole number, maybe a half, maybe there might be a half, but that's about it. So, okay, 5, -1, is that it though, right? So we're going to check wherever you have room, right? So for 1, you have left-hand side, right-hand side. So the first one is 2x minus 5y is equal to 15. You plug in the values, 2 times 5 minus 5 times -1, right? Make sure that negative comes in here and there's a double negative. So it's actually 10 plus 5, so that's 15. Left-hand side is equal to right-hand side. That's good. And then the second one we'll also check. So that's what verifying your solution means. You have to do the check, right? Y minus, y minus 3 is on the left, and on the right you have 2/3 x plus 1. Right? If you look at this equation, left-hand side is this. So then you plug in -1 minus 3, that's -4. And on the other side, you have -2/3. 5 plus 1, that's -2/3 times 6, right? Let's do some canceling here. The 3 goes in here twice and goes in there once. So it's really -2 times 2, which is -4. Right? So left-hand side is equal to right-hand side. Therefore, 5, -1 is a solution. The solution. I'm mixing it up with my other course, grade 11 applied that I'm teaching right now, where it's a little different, but it's the solution. It's where the lines meet, right? The point of intersection is the solution you've checked, right? So Mark allocation, I would say you get right now, just for this particular example, okay, I would say you get 2 marks for the work and the graph, right? So all of that combined would give you 2 marks. And then verifying your solution is going to be 1 mark. Okay, so the verifying and actually coming up with the final answer will make that worth 1. And all the work that went into graphing and the graph itself, we're going to make that worth 2. So three marks if you did all the work, if you labeled correctly, right? Your lines are labeled and you identify the point of intersection and you actually stated that that's the solution. 3 out of 3. If any of that is missing, I would take off half for missed labels and so forth. Okay. All right, I'm going to move on. Less work, right? But marks are still there. So Santa's Workshop makes train sets and model planes. It costs $25 to make a train and $30 to make a plane. His elves can produce 200 toys, spending $7,500. Write a system of equations that model this scenario. Let me just check one thing here. I want to make sure I entered. Oh, okay. Okay. This one will be interesting. So 200 and spending 7,500. Write a system of equations that model the scenario. So let's go through the steps. We will let X be the number of train sets, and Y will be the number of planes, right? So that should be there to make sure. So I would say this is worth a half a mark, or you will lose half a mark if you didn't do it. Let's put it that way. And then so write a system of equations. We have that they can produce 200 toys. So the number of trains and planes is going to be equal to 200. That should be one equation. And then when it comes to cost, since it costs $25 to make a train and $30 to make a plane, right? That is going to be equal to 7,500, like that. Okay, so if you wrote these two and you included the train set, I would say you get 2 marks. So I will erase the half mark here, but I'm focusing primarily on the equation, so 1 for each. And then take off half if you forgot to introduce your variables. Okay. And then for B, verify that producing 150 trains and 50 planes is a solution to the system. And based on, I forgot to change one of the numbers, so it technically shouldn't be, so we'll check. So for the first, we're going to check the first and the second. So the first equation, left-hand side, right-hand side, we have x plus y, and this is 200. So 150 plus 50 is 200. So here left-hand side is equal to right-hand side. So far we're good. But for the second one, it probably won't work out. And that's okay. That I actually want that to happen every once in a while. 25 times 150 plus 30 times 50 is supposed to be 7,500. So let's see here. That's 3,750 plus 1,500. Plus 3,750, that's 5,250 left-hand side is not equal to right-hand side. Therefore, 150, 50 is not a solution to the system. Okay. When I made this question, right, I actually used Desmos and I just plug in and see what works. And this was supposed to be, the planes were supposed to cost $75 to make. And I forgot to change that. But I'm glad it happened because now you found have an example where the solution is actually not right. The proposed solution is actually not the solution to the system. So that's what you should conclude, right? That's not. It satisfies one equation, but it does not satisfy the other. Okay, so that's that. So this is a total out of 7. Give yourselves a mark out of 7 at the top, right? It's out of 7, and I will make a slot available, and then